Hello students, once again welcome to Bholanath Academy. In this video students we are going to prepare the phenols, that is preparation of phenols. Now here students, four raw material that we are going to use here to prepare phenol. Phenol is very important compound to prepare many commercial product. Preparation of phenol students. So first raw material that we are going to take, that is called as chlorobenzene. We are taking the raw material chlorobenzene students. Benzene, one of the hydrogen of benzene is replaced by chlorine, we call as chlorobenzene, and the process, if you are using chlorobenzene, the process we call as Dawes process. This is also called as Dawes process students. Mind well, chlorobenzene, if you want to convert into phenol, the process which is used, that is called as Dawes process. Now what happens, how you will prepare students, when chlorobenzene is fused with NaOH. First students, you have to take the chlorobenzene and you have to fused with NaOH at about 623 Kelvin under a pressure about 150 atmosphere, that is nothing but 1.5 into 10⁷ Newton per meter square formed. Now when students it will fuse, it will form sodium phenoxide. Very important students, after fusion it will form sodium phenoxide, which is acidified. Then sodium phenoxide, when you acidify with dilute acid, that is HCl, you will obtain phenol. Understanding students? Now we will see the reaction students. So first students, we will take the, you have to write down the structure of chlorobenzene. So students, benzene structure, you know, this is where you are representing the benzene. There is an alternate double bond. One of the hydrogen of benzene you are replacing with chlorine. Now this is your chlorobenzene. So students, this chlorobenzene, when you are fused with NaOH, this is NaOH students, compound you are fusing with NaOH at 6, you have to heat, if you heat at 623 Kelvin, okay students, or you can put the symbol of this is the symbol students, triangle stands for, you have to heat this chlorobenzene, you have to heat with sodium hydroxide at pressure students 150 atmospheric pressure, we call as 150 atm. Now what happens students, it will form sodium phenoxide. So students, this NaO will form salt. This is the salt students. Oxygen will carry negative charge and sodium is always positive. So because of these charges students, this is the salt students, you are getting sodium phenoxide, and because you have used two molecules of NaOH, there is a formation of sodium chloride and water molecule. Okay students, so this is called as sodium. The name you have to start from this side students. Na plus is nothing but sodium, and this whole compound is nothing but it is phenoxide. So formation of phenoxide is very students, when it is fused it will form sodium phenoxide. Sodium phenoxide as a solid student, it is very stable students. This is sodium phenoxide. Now when you acidify it with dilute HCl, you have to dilute HCl, that means you are getting S3, acidic water, hydrolysis. What happens students, here the sodium plus will combine with chloride of HCl and it will form NaCl as a byproduct, and what happens with this hydrogen will come here and it will form the phenol. Understanding students? So this way students, you have prepared the phenol, very important for the examination point of view students. From chlorobenzene we have prepared the phenol and NaCl as a byproduct. Second raw material that we are going to use, that is called as CUMENE. CUMENE is the common name students. CUMENE is what? Common name. Now when you see the IUPAC name students, or you can say chemical name, is isopropyl benzene. Since benzene is attached to the isopropyl, it is called as isopropyl benzene. First write down the structure of isopropyl students. Now this is isopropyl students. Now one of the hydrogen here is you are replacing by benzene ring. So this is isopropyl, or you can say CUMENE, or you can say is called as isopropyl, and here the benzene is attached, so it is called as isopropyl benzene. Understanding students? Now what happens students, when CUMENE, now read it, very important students, when CUMENE, that is isopropyl benzene, on air oxidation in presence of cobalt naphthenate, gives CUMENE hydroperoxide. So oxidation will take place in presence of cobalt naphthenate. Very important students, you have to heat this CUMENE in presence of cobalt naphthenate. You have to write like this students in examination, then only you will get the full marks. This reaction is very important students. Examiner will see the reaction only. So write down, once you know the reaction you can write in words also. So students, this CUMENE combines with the oxygen in presence of cobalt naphthenate, gives CUMENE hydroperoxide. So this way students, you can write CUMENE structure students. Now what happens here, the oxygen will attach to the hydrogen. They will addition reaction will oxygen will added to this cumene. So these two oxygen will go and they will attach like this. And this methyl group I am writing here, students. So CH3, CH3. Okay, students. These two methyl group I have written like this. So there is a oxidation. In oxidation, students, this oxygen will added to the cumene and it will form cumene hydroperoxide. Cumene is nothing but isopropyl benzene and hydroperoxide. So you can also write, students. Okay, students. So this now once you got this, students, what happens, students? Which on decomposition with dilute acid. Now this compound, students, cumene hydroperoxide will decompose with dilute acid, gives phenol. Understanding your byproduct will be acetone along with acetone as a bioproduct. So what happens, students? Once it will form the cumene peroxide, dilute sulfuric acid you can use, students. Just heat it. What happens, students? It will decompose. The decomposition will take place. Now the decomposition will take place, students, like this. It will decompose and it will form. Now this OH will now combines with benzene and you will get the phenol. When you heat, students, this part will break and the part which will be there as a byproduct, that will be your acetones. Okay, students, you will get the acetone as a byproduct. Okay, students, very important byproduct, students. So this way, students, you have prepared the phenol from the cumene. Now third raw material that we are going to use, students, from benzene sulfonic acid. So students, benzene sulfonic acid on neutralization by NaOH, since it is acid, we have to neutralize with base, that is NaOH, gives sodium benzene sulfonate. It will produce sodium benzene sulfonate, which on fusion with solid NaOH at 573 Kelvin gives sodium phenoxide as a salt. Now once you got the sodium phenoxide, students, followed by that you have to add dilute acid and it will produce phenols. Here the raw material is benzene sulfonic acid. So write down the structure of benzene sulfonic acid, students. Since here your benzene ring should be there, students, attached to sulfonic group, that is SO3H. So this structure is very important, students. Once you are able to write down benzene sulfonic acid, this is the raw material structure, students. Benzene sulfonic acid, SO3H. One of the hydrogen of sulfuric acid now you are replacing with benzene. So this is benzene sulfonic acid, H2SO4. Now what happens, students? This is the benzene sulfonic acid, students. Now when you are neutral, this is acid. Since it is acid, now to remember, students, you have to use base. If you want to neutralize, you have to use the base. So NaOH is very important base, students. Now when you add, students, you will get salt of acid, that is sodium benzene sulfonate. Understanding, students? You will get, there is a water molecule will be liberated and you are getting water molecules as OH of this react with hydrogen of this benzene sulfonic acid and form water molecules. And what happens, students? This sodium will form the salt of acid like this, students, SO3 Na. SO3 will be negative and Na plus. So this is the salt, students, that is salt name. You have to start the naming from here, students. That is called as sodium benzene and it is a derivative of sulfonic acid. So we will write sodium benzene sulfonate. Once you prepared sodium benzene sulfonate, students, now this salt you have to fused with solid NaOH. Once more time we are using sodium hydroxide, students. So once again we write sodium benzene sulfonate. This is the salt, students. SO3 will be negative and sodium will be positive. This sodium benzene sulfonate, this is the sodium benzene sulfonate, students. Now you have to fused with sodium hydroxide, that is NaOH, at 573 Kelvin. If you are not able to remember this digit, students, you can just put that symbol and you have to write fused. Now what happens, students? After fusion it will form sodium phenoxide. Okay, students. So this Na2 will be first, Na2 combines with SO3 form sodium sulfate. Okay, students. Now what happens, students? There is an elimination of water molecule from here also. Now what is remaining? Only one sodium is remaining, students. Now it will form sodium phenoxide like this. So sodium oxygen will be negative and sodium will be positive. There is a formation of sodium phenoxide. This is the phenoxide, students. This is the, again you have got the salt, that is sodium phenoxide. Now students, this sodium phenoxide, this salt, students, on acidic hydrolysis you will get the, this combines with oxygen, here this will be negative charge, this is positive, so this positive will go and it will form the phenol. Okay students, this is the phenols, and you are getting NaCl as a byproduct. So this way students, we have prepared the phenol from benzene sulfonic acid. Very important students for the examination. This way you have to represent the answer. Now students, last raw material that we are going to use, that is called as from aniline. Okay students, aniline. Aniline is treated with nitrous acid. See, aniline is base students, you have to use the acid now. If you want to neutralize the aniline students, you have to use the nitrous acid. Nitrous acid, how you are going to prepare it? Sodium nitrate combines with HCl. This is the nitrous acid students. At low temperature, you have to keep this mixture in an ice bath to reduce the temperature. That is why it is written here what? Low temperature. To obtain, this is the salt students, benzene diazonium chloride. So students, aniline is base, you have to neutralize with acid, that is nitrous acid, which is very important students. At low temperature, you have to keep the mixture in ice bath. Then what happens students, you will find benzene diazonium chloride as a salt, which on hydrolysis students you are getting phenol. Very important for the examination point of view students, how aniline you are converting this base, aniline you are converting into what? Phenol. So students, you should able to write the structure of aniline first. So aniline, how you are writing students? So this is the benzene students, where one of the hydrogen of ammonia replacing by benzene. So this is the structure of aniline. This is the common name students, aniline, or you can say aminobenzene. It is a derivative of amino acid ammonia, that is it is also called as aminobenzene, which is basic in nature students. If you want, that is why we are using nitrous acid. We are using nitrous acids, Na, NO2 and 2HCl. In this ratio students, you have to add 1 volume of NO2 combines with 2 volume of HCl. It will give you nitrous acid. Now students, what happens students? This will be at low temperature. Low temperature students, very important. Or you can also write at a 273 Kelvin. 278 Kelvin is called a low temperature. Understand, that is ice bath. You have to use ice bath. Okay students, so this is the low temperature. You can write low temperature, or you can write this, or you can write what? Ice bath. Now students, what happens students? It will form diazonium salt. So this is the nitrogen and this is the nitrogen. Will form Na2, and here from here you are getting chlorine. So there is a formation of diazonium salt students. Diazonium means di means there will be 2 nitrogen, and that will be always positive di, and since it is a salt, there should be chloride. And since diazonium, benzene diazonium chloride, diazonium, this is diazonium chloride. If it is attached with benzene students, we call as benzene diazonium chloride. Along with this students, you are getting NaCl plus water molecules. Understanding students? Once you got benzene diazonium chloride students, what happens students? Against this benzene diazonium chloride, now this benzene diazonium chloride on hydrolysis, H2O, and just heat it. What happens students? On hydrolysis, this N2 will liberated as a nitrogen gas. And what happens students? And the hydrogen, one of the hydrogen of water molecule will combines with chlorine and it will form HCl. Now what is remaining? OH, that will combines with benzene and you will get the phenol. Okay students, so this way students, you have got the phenol. Very important for the examination point of view students. So here students, nitrogen gas and HCl you are getting as a byproduct. Our product is phenol. So this way students, we have prepared the phenol from aniline. So this is very important for the board examination. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.